Okay, I was just going to summarize software development for you, but it strikes me that you've got a homework assignment where you're going to try to build a solver for your retirement or for paying off your college savings. And maybe the Steve drive to the cabin example isn't sufficient to see exactly what an agile software development would look like. So I'm going to do a second one. Last year, when we were teaching this class, one of the students in the class, his name was Vitali. He and his wife were having a baby during the course of the fall, and so during the semester he's going to have a baby. And we commented that, hey, I hope you're saving for college now. And with this blank look over his face, like, what do you mean saving for college now? I'm in college, right? And so we in the class created a quick solver, and I'll do it for you right now in an agile software way. How much money should Vitali be saving for his brand new baby? So we're going to say baby born. So form a scrum. I'm the scrum. We're going to do brainstorming. I'm going to limit this since we don't have much time. I'm going to limit this to Vitali's baby is going to go to the University of Minnesota. So University of Minnesota has tuition right now of $27,469. That's in-state tuition. That includes tuition, fees, room, board, books, supplies. Do people buy books anymore? Anyway, whatever. Books, supplies, and like $2,000 for other miscellaneous stuff. So that's Vitali, his bill per year for his new baby. The baby is born here and turns 1 and 2 and 3 and 4 and so forth. The baby finishes high school. Hello, drag. After 18 years, and then the baby is at the University of Minnesota for 4 years. Hopefully only 4 years, right? Okay, so the reason I drag this out is because tuitions don't stay the same. It turns out tuitions have been going up 2.9% a year for the last few decades. So what we're going to do is we're going to say this equals that times 1 plus this. And I want to lock that cell. Okay, so now let's format this. Okay, so you can see, let's see if I did this right. Yeah. Okay, so tuition is going up. And by the time Vitali's kid gets to college, that 2.9% per year drives that $27,000 up to $47,000. And in fact, it ends at $51,000. So, Vitali, you are kind of in trouble. You better start saving some money now. So let's see, how much is Vitali going to save per month? We'll solve for this, but I'll put in $200 right now. So he's going to save $200 a month. And as he gets further along in his career, he's going to be able to save more money for his kid. So that $200 a month isn't going to be static over the whole life of the child. It's going to go up by some percent increase every year. And let's say that's a, 10%. Okay, so in year one, he's going to save $200 a month. Let's see, this is per year. Dollars per year would be that times 12. We can just drag that down. Okay, thank you much. Okay, and then his dollars per month is going to go up, equals that times 1 plus this, where this number doesn't change. Okay, so we'll just drag that down. So when the baby's 1, he'll save $220 a month and $242, and so on and so forth. Okay, so by the time the kid's in college, he's going to be up to like $1,200 a month. And we'll put this in format painter. Okay, so now you can see how much he's saving per year. Now, I can tell already this isn't going to work because by the time dollars per year, if you add up this whole column, it's $190,000. He needs, oh, $197,000. Oh, this might actually work. So what we're going to do is we're going to say how much does he have in his fund, and at the end of the first year he has that amount, which is how much he's put in. And then he also has an interest because he's going to invest it, right? So the interest rate, let's see, interest rate. Let's say he gets 6% on his investment. So in his second year, the fund value is going to be, how much did he start with? How much did he start with? Times 1 plus the interest rate, which I want to lock. Dollar signs, by the way, lock the cell, so when you drag it, it doesn't change. So $2,400 plus 6% interest on the $2,400 plus his new investment of this year, $2,460. Great. So let's do painter. I don't need it all. Okay, and let's just drag that down. Let's see if it works. How does that work? So this 5 plus 6%, so that'd be like 5 plus 3 is $8,000. But 6% on top of 5 would be another couple $100. So okay, all right. Yep, okay. So this is his total fund value at when the baby's 4 years old. The total fund value is going to be $14,000, and then by the time the kid finishes high school, the fund value will be $122,000. These 4 years, the fund value is going to be different. It's going to be, let's see, I'll drag it down one more. It's going to be I-21 times 6% plus the amount he puts in for that year minus tuition, which is now $47,000. Okay, so instead of going up, it went down, and boom. Okay, so if Vitali, as we said at the beginning, saves $200 a month, and he increases it 10% every year, and he gets a 6% interest rate or return on his investment for all of his money, he's going to come up about $6,000 short, which is actually pretty close. But let's be precise. We will use goal seek this time. I want to set this value, set that cell to be 0 by changing his initial monthly contribution, which would be way up here. There we go. Okay. So if Vitali starts at $207 a month, increases at 10% every year, and gets a 6% rate of interest on his investment, he will be at precisely $0 at the end, but after paying $197,000 for his kids' University of Minnesota education. So Vitali, our hypothetical student from last year, needs to start saving $207 a month, and start increasing that 10% every year. Okay, so we still have 6 minutes left. This agile software development went a lot faster than the Steve Drive to the Cabin software development. What we should probably do is make it easier for users. So let's put some user instructions. First, enter starting. Enter tuition in today's dollars, cell C3. Second, enter tuition inflation assumption, cell C1. Okay. Third, enter interest rate assumption for investment. And I think that's it. Fourth, run goal seek on cell. Oh, I guess I should have said this is in J2. Cell J2. Run the goal seek for cell I25. I25 equal to 0 by changing cell F3. Okay, there's the instructions, and so now I have a tool, and you know what I could even do is, make this tool a little more user-friendly, put the things you're going to enter in yellow. All right, you're going to update these 3 things, and go down here, make this one something obvious, maybe a green, and now I've got user instructions. I'm drawing their attention to the cells they need to change. You know what I did not do for this software development? I did not validate this. I just ran it once and said, hey, good enough. So let's play with it a bit. Let's say tuition was only $10,000. Let's say inflation is only 1%. And let's see what the goal seek does. Data, goal seek, change it to 0 by changing cell F3, right? F3. Okay, so that makes a lot of sense. You only need $51 a month if tuition's $10,000, and the tuition inflation, I should probably say that, tuition inflation equals only 1%. All right, so let's go to the other extreme. Let's say you're going to go to a private school. My wife went to Rensselaer Polytechnic Institute in the 90s, and it was $26,000 a year, all in. Now it is $72,000 a year. $72,000 a year. And it's going up like 3.5%. Ouch. Look, the numbers get so big I need to make the cells bigger. All right, so let's say, okay, say 6% interest rate. That's how much we're going to get. Ooh, this is going to be ugly. All right, we're going to do data, goal seek, set it to 0 by changing F3. Let's see how ugly this is. Okay, so, oh, wow, that's pretty ugly. You need to start at birth with $611 a month and grow that 10% every year, and that would be for Rensselaer Polytech Institute. And in total, you will spend $583,000 on 4 years of college at RPI. Okay, so now I hope what you've seen here is, and I better wrap this up, I've only got 30 seconds left. Another agile software development. This one went a lot quicker. This one now has user instructions. This one has been validated. It looks like it makes sense. Looks like it's working. I could make some more enhancements on it. For example, let users play with this as well. How much their percent increase goes up each year. Let me know if this does not provide you the direction you need to get your homework complete. Thanks.